As many of you know, Minnesota is the land of 10,000 lakes, and it was in one of these lakes, this one in fact, that the concept of an ecosystem was first formally defined. This is Cedar Bog Lake, just 35 miles north of here. What is an ecosystem? Where does it start? Where does it end? What's included? What's not included? In 1942, Ray Lindeman offered this definition of an ecosystem. Various forms of this definition continue to appear in nearly every biology and ecology textbook. We use this term ecosystem so often that we often forget how transformative his notion of an ecosystem was. At the time he proposed this definition, people studied species one at a time, or perhaps they studied several plants or several animals. And Lindeman was perhaps the first person to think about connections not only between plants and animals and bacteria, but also the chemical processes studied in chemistry, physical processes studied in physics, as you can see by this definition. He de-emphasized the boundaries of the ecosystem, saying that it could be considered to be a very small thing or a very large thing. Instead, he emphasized the all-inclusiveness of the concept, including the abiotic non-living components, the biotic living components. And clearly this includes everything. Everything's either alive or it's not alive. The key in Lindeman's perspective was to investigate the entire integrated system, and he did so in this small lake. After studying this lake, he produced this transformative diagram, which shows how energy flows through ecosystems, how materials recycle within ecosystems. He organized all the components of that system into a food web that has cycles. We see the sun's energy coming in from the top, being captured by the phytoplankton and the pond weeds, being transferred up to higher trophic levels as those plants are consumed by browsers, or the phytoplankton are consumed by zooplankton, on up to higher predators, including the swimming fish at the top of this food web, located at the bottom, but the higher trophic levels of this food web. Material is then recycled through decomposition that occurs in the ooze that he placed at the center of this diagram. And if you've been to Cedar Bog Lake, you know that ooze belongs at the center of this diagram. If you, some of you are laughing because you've been there. If you wade around in the ecosystem, you'll immediately feel the mud between your toes, and before long you might feel it all the way up to your neck. He importantly noted the inefficiency of these energy transfers. We see lines coming off each of these trophic levels where we have a loss of energy. For example, if we consider a predator-prey relationship, Lindeman approximated that perhaps only 10% of the energy included in the material of that resource is incorporated into the material of that consumer predator species. The other 90% of that energy is lost during that transfer, partly by inefficient digestion or through respiration processes. This highly inefficient feeding process partly explains why we have very few top predators in systems, why we have many more plants than we have herbivores, many more herbivores than we have top predators. Who was Lindeman? He, as many of you know, he was born in Minnesota, and he lived in Minnesota for nearly all his life. His interaction with the University of Minnesota came at the time that he was a graduate student here in the late 1930s. As you can see from this picture, he was far better dressed than most of our current graduate students and faculty, I might add. University of Minnesota did not yet own the property that includes Cedar Bog Lake when he did his studies there. That property was acquired when just at the end of his time working there at Cedar Bog Lake. There was no EEB department at this time. Instead, faculty and students were organized into zoology and botany departments. Lindeman obtained his PhD in zoology, but he was heavily influenced by faculty in botany as well. And you can see from his food web diagrams that he needed expertise from all of these areas. In particular, William Skinner Cooper was a botany faculty member who encouraged Lindeman to work at Cedar Bog Lake, and who also hosted Lindeman in seminar discussion groups at his home, and encouraged him and challenged him in his ideas of ecosystems as he began to develop these early concepts. More than anyone else, though, Ray's wife, Eleanor, was critical for his success. She was both a scientific collaborator, she's pictured here with him. She was both a scientific collaborator and expert in diatoms. She was also a hard worker in the field. And finally, she was a caretaker for Ray, both at home and with his field work. Early in his life, Ray lost most of the vision in one eye due to an accident with iodine. And throughout his adult life, he was perpetually ill, suffering from both chronic colitis and hepatitis, the latter of which led to his untimely death at the young age of 26, just before his 27th birthday and a few months before his most famous paper was published. But his legacy lives on. Thousands of K-12 students now visit Cedar Bog Lake each year. They enjoy a nature hike, they learn about ecosystems, and they get to see the place where Lindeman first put together an understanding of nature. These young students are inspired by walking in Lindeman's footsteps, not only because he's a character from their textbook, but also because he's a fellow Minnesotan. Lindeman's ideas also inform contemporary discussions regarding how our diet choices affect global demand for cropland. Lindeman noted, even in his 1942 paper, that it may be more efficient for people to get calories directly from plants than from eating animals that consumed plants. Although this discussion has now advanced well beyond this simple principle, it's interesting to note that Lindeman's ideas remain relevant even to these current discussions. More broadly, Lindeman's view of nature as an integrated system was necessary for us to appreciate how human impacts on the global carbon cycle are changing the climate. This diagram shows the global carbon cycle, and it's amazing that we can now estimate the pools and fluxes of carbon. How much carbon is there in the atmosphere, in the rocks, in the soils, in the plants, the ocean, and how much is flowing between these various pools. This includes quantifying how much carbon humans are putting up into the atmosphere, shown here in red, for the numbers in red. And we see that about half of what we put up stays up there in the atmosphere, contributing to warming, and the other half is soaked up by land plants through the process of photosynthesis, or is taken up by the oceans. And so Lindeman's ideas continue to not only increase our understanding of human impacts on nature, but also the benefits that people get from nature. These are just a few of the ways in which Lindeman's ideas continue to inspire young people and help us discover sustainable solutions to environmental challenges. If you look closely, you may see evidence of Lindeman's impacts in some of the talks that will follow. As we transition to the next speaker, I'll leave you with an excerpt from a poem that Lindeman wrote about a different lake in Minnesota, Itasca.